Hi everyone, welcome to Cloud Ranger's Microsoft Azure training. This is the 2018 edition. I'm Sean Ismail. The blue bar below has my Twitter, blog, and LinkedIn info to connect to me. You are probably watching this on YouTube right now at that location. The course resources are located on GitHub, and the slides that I'm presenting right now for this lesson will be posted on slideshare.net. So let's introduce today Module 2. This is implementing and managing Azure networking, and this is the lesson 1 overview of Azure networking. So let's get started. The overview of Module 3 in general, the lesson 1, today's overview of Azure networking. Lesson 2 would be implementing and managing virtual networks. Lesson 3 will be configuring an Azure virtual network, and fourth lesson will be configuring virtual network connectivity. So let me tell you, this is probably one of the most important lesson that we will have in this entire series because networking is one of the primary building blocks of, in general, infrastructure in Microsoft Azure. So everything is built first around a network or in a network. That's why it will be one of the most important one. The overview of Azure networking lesson, the one we have today, is going to be a little conceptual or theoretical. I'm not going to get on a portal or command line and actually build anything, but pay a little bit attention in figuring out what we are talking about because this will be the fundamental building block to all the other lessons when we get into virtual machines, infrastructure as a service in general. You'll find out a lot of networking comes even in platform as a service. So it's quite important. I must also give you a heads up that this is one of the lessons where it gets a little tricky. And by tricky, I mean that if you don't have too much experience in IT in general, you're going to have a little bit of a hard time trying to understand most of the concepts. If you're already in IT, then you'll appreciate the lesson we'll have in Azure networking overall because you'll find out how things are more easier in cloud environment. This is not to discourage folks who are already, think of making a career change because I get emails every now and then that, hey, I'm in a different field. I want to get into IT. I've been hearing of this cloud thing. How do I get started and all that? I typically say that have some fundamentals that you have or you will need to actually get into cloud. Cloud is actually advanced in a very elegant and simple way. If you don't know networking at all, you don't know what a switch is, what a router is, what a server is, it's a little bit harder because you have to now go and look it up on the internet or maybe read a book, one or two, couple of chapters here and there to get some of the fundamentals to understand, right? So that's not to discourage you, just to, give you a heads up that having some background at this point will definitely help you understand this or navigate through these lessons a little bit quicker or grasp the new cloud concepts in a more easy fashion than going to cloud where things are a little bit advanced already, but you're trying to figure out what a router or a switch or a server is. It's going to get a little hard. Okay, so let's get started. The first thing I want to do in this lesson is introduce you to the Azure networking components. Like what are the components that eventually in Azure networking will bring everything together. So the first thing we're going to talk about is virtual networks. So this is network in general. Azure refers it to a VNet or a virtual network, I guess, VNet. You'll hear VNet quite a bit. You'll read documents where it'll be referred to as VNet. With that comes the subnets, network interface cards, IP addresses. I'm not going to go crazy into IP address spacing or how subnetting and everything works. I'm assuming you have some idea of it. Otherwise, read it up, how IP addressing works, public as well as private IP addresses. We're going to introduce network security groups, virtual network DNS and Azure DNS. I'll again describe what are the differences between this and how this is unique. Azure load balancers, Azure application gateway, Azure traffic manager, routing. Again, I'm not going to get into static routing, dynamic routing, and all those things. I'm going to just briefly give you an overview of the routing that Azure can do for you. And then we are going to talk about virtual network connectivity, a little bit about hybrid networking will get introduced in this concept, and we're going to talk about virtual network gateway. So this is pretty exhaustive list of all the networking components. Obviously, the cloud is changing. Microsoft adds and removes things every now and then. They change the name a little bit here and there, but typically that's what will constitute in the networking components. So we'll get started with the virtual network. So if you are familiar with on-premises network, you know how an on-premise network gets built, you'll find out that this is so easy to do on Azure, right? It serves the same purpose as the on-premises network, and the fundamentals are pretty much the same. The Azure VNets allow basically Azure resources to communicate both with each other as well as the internet. So I have a little diagram over here. As you can see, this is actually a network. It's a VNet. It has its address space. I have two virtual machines in here, server 1 and server 2 with their IP addresses. Basically to create, this is as simple of a virtual network that it can be, where these two servers can communicate with each other. Okay, and these servers over here can also reach the internet without anything else present in here. Some of you, on-premises folks are probably now thinking of where the firewall is, where the gateway to get to the internet is. I'll get to that in a bit, but this is the most basic of a virtual network diagram that I can have over here. And the other thing that virtual network allows you to do is it's used for resource isolation, right? So if you have bunch of subnets in there or you have separate networks created, they're all in isolation within the context or domain of the virtual network. Virtual networks can be connected to other virtual networks. So if you have a VNet over here, you can connect it to another VNet. There are use cases for that, and I'll get to that in a bit. It can be also used to connect to on-premises network. So if you have a virtual network that's created on the cloud and you have a network on premises in a data center or somewhere, you can actually have a connectivity between them. So it can be used for that. So while the virtual network is very similar to the on-premises network, it has its native cloud characteristics, and more when we build virtual networks or when I explain more about that, you'll understand some of the things that are very unique to the cloud architecture in general. Okay. All Azure virtual machines deploy to a VNet. So if I wanted to deploy server one by itself, you cannot just do that. You have to have it part of a virtual network. So that means the VNet needs to be configured first. That's why, it's very important that you understand, and that's what I mean by that VNet being a fundamental building block is exactly that. You need to create that first before other things can happen. Now, to get into some little nitty-gritty details over here, VNets support TCP, UDP, and ICMP. I have a little bit of a typo there, but it's TCP and UDP and ICMP. It doesn't allow, multicasting or broadcasting on the network, just for you networking folks who are a little bit curious on what's it supported. So a lot of things will happen with Azure Virtual Network. Subsequently, the next slides that follow are things that happen in or around virtual network to support it. Okay, but this is the most important one, the VNet. Now next go to VNet subnets. So if you already are familiar with a subnet, then this is exactly what it is. It's a subnet. For you folks, a subnet actually is used to facilitate resource isolation or segmentation within a single network. If you remember VLANs, once again for the network force, I'm kind of synonymously using, VLANs and subnets. They're not necessarily, usually for most contexts, they're one-to-one, mean the same thing, but it's a little different, as you can imagine. But it serves the same purpose, right? Each subnet contains a range of IP addresses, as you can imagine. So it's a subset of the VNet address space. And Azure VNet subnets facilitate resources to communicate among each other. So let me explain you a little bit of what that means. If you look at the diagram over here, it's very similar to the previous one, where I have a virtual network. I have an address space. It's a 16-bit subnet masks. I'm starting with 10.3.0.0. So anything after 10.3 will be supported in this address space. It's a private network, as you can imagine. I have three subnets over here. That is subnet 1, subnet 2, and subnet 3. And within the subnet, this was 10.3.0.0 space. I'm going to take 10.3.1. It's a 24-bit mask or 24-bit subnet. 10.3.2 here, 10.3.3 here. So the service that I created within this subnet is 10.3.1.5, 10.3.1.6, as you can imagine. This one is 10.3.2.5. 2.6, this is 3.5 and 3.6. So the subnet will provide isolation in this entire network. So I'm segmenting this network in three parts. Having said that, these virtual machines within the subnets actually can communicate with each other or connect to each other. Now, if I have to get really into the networking side, how do you do that on premises? So today you can probably do this on premises. So this virtual network is one switch. Within the switch, you will create three separate subnets or three separate VLANs, and you'll have those addresses spacing in there. Now, if it's a layer, so okay, before I even get to that, this subnet would communicate with this subnet. It probably will have a router and go to that router and say, hey, 10.3.1, I want to go to 10.3.2. It will route you to there. That's where you'll need a router. Or these days you can have layer 3 switches. Even though, switch is a layer 2 device, it's a layer 3 switch. That means that the switch itself supports routing between these subnets so they can communicate with each other. Now, this is where I meant by you traditional folks appreciating this a lot, is that when you deploy a virtual network in Azure and you have subnets, that's all is already done for you. Okay, so these servers can actually all communicate with each other. You don't have to go create VLANs and subnets and address spacing. You basically just go and create the virtual network. You say you need three subnets, and this will be the address spacing. It kind of knows what to do from there. Okay, now, I'll get to the point where isolation really comes in, means that if I really don't want this server to communicate with this server, how would I prevent that? In the next few slides, I'll actually explain that. But that's what the subnets do in a VNet. Now, network interface card, some of you might be wondering why am I explaining this? For Azure, this is actually very important. So as you can imagine, Azure virtual machines use virtual network adapters, like any server, physical server, or a PC you are on, or a laptop. It might have a RJ45 connection or Wi-Fi connection. It means it has a network adapter, similar to virtual machines here. The network adapter connect to VNet subnets for network communication. So all those it will be connected to the subnet. So the subnet is aware of the network interface card or NICs that you have. And one thing to remember is quite easily you can associate multiple NICs or network adapters to a single virtual machine. It depends on the virtual machine size. So I'm not going to get into much of the virtual machine sizes, but there is this whole separate lesson or module completely dedicated to that. But you'll have to remember that every virtual machine at least require one network interface card or NIC to connect to everything else. So it's important. Okay, and multiple, different sizes of virtual machines that are present in Azure will allow you to use multiple networks depending on what the size is. So Azure IP addresses, like I mentioned before, I'm not going to get into subnetting and crazy, calculation of, how IP addressing will be allocated and all that in this lesson. But from Azure perspective, you have to remember Azure provides unique IP addresses to network-enabled devices, which could be a virtual machine, a network appliance, or anything like that. Two types of IP addresses are provided by Azure. The private IP addresses, the one I was showing earlier in the previous slide, it was a private IP address. It allows for internal network communications, sort of. The reason I say sort of, because it can go beyond internal networking, but I don't want to get into all of that right now. But remember that anything internal to a network will have a private IP address to communicate at least with each other. Then you have public IP addresses. It allows basically connectivity to the internet. So if you have a virtual machine, it has a private IP address, but it will also need a public IP address to actually go out, right? In public IP addresses, there are two SKUs. One is a basic SKU, which supports both dynamic and static allocation method. So that means if it's a public IP address, you can have a static public IP address that doesn't change, or you can have a dynamic one, which is leased to you, but it can change. Okay, for the purpose of just this one, I'll leave it at that. I mean, this lesson, I'll leave it at that. Then you have the standard SKU, which supports only static allocation method. Like if you want a static IP address, because it's like, let's say it's a web server or FTP server or something that your clients or your users connect to from the internet, you probably don't want them to change, right? Because you will have a DNS name for it. So you need a standard SKU for that. Now, are there differences between the basic and the standard? There's actually quite a bit, and it depends on the resources that it will be connected to or other resources that it will be using. So for example, a public IP address is not necessarily only for a virtual machine, it could be for a load balancer. So if you have a load balancer, which you will find has also a basic and standard, depending on what characteristics it has, you'll have to assign a basic or standard one. If that doesn't make sense right now, don't worry about it. But for now, you have to remember for Azure IP addresses, you have those two types. Okay. Network security groups. This is actually a little unique to cloud platforms in general. I'm not going to say just Azure, other cloud platforms have similar things. So, what network security groups do is that it's used to filter inbound and outbound traffic to Azure resources. Okay, so basically a collection of firewall rules that can be associated to a VNet. It is what exactly allows for creating subnet isolation, and it can be set on a subnet or it can be set on a excuse me, on a virtual network directly for granular controls. So if I can go back to the slide I had earlier over here, you'd have a network security group over here. You'd have a network security group over here. You'll have a network security group over here. So if a server one wants to go to from subnet one to subnet two, you can actually have a network security group applied to this subnet, and it will allow a specific type of traffic. Let's say you want this web server connecting to this database server, and you don't want any other traffic to go from this subnet to this subnet. So essentially, you let the network security group over here say with a rule that allow traffic from subnet 1 to me over here, subnet 2, and only allow this specific ports to come from subnet 1. Any other traffic, you just block it. So if you are thinking that this is a lot like a firewall that you are using on premises, you are quite correct. It's very similar to that. Now, this is where I say that you'll really appreciate the cloud platform is that, typically to do this on premises, you'll have to get the firewall, you have to set it up, you have to do a lot of things. Depending on the type of firewalls, you may need three, or you may have one firewall with multiple contexts to actually do all of that. It's quite a bit of a work, but you will see in the next lesson when we are actually building this up that with a couple of clicks, you can actually have this built in minutes in this environment over here. So once you have the network security groups associated to these subnets, that's when the isolation comes in, right? Let's say that this subnet over here does not allow any traffic except people remoting in there and doing some stuff. You can actually have your network security group rules assigned that way, saying that don't allow any traffic over here except for these servers to communicate with each other. That's what the isolation is all about. Okay. So network security groups, it's quite unique to the cloud platform, and we'll talk a lot about that when it comes to subnetting or when we are talking about security in Azure. Okay. And one thing to remember from your exam perspective, network security groups can be applied at a subnet level. It can be applied to a virtual machine network card directly for granular controls. It can be used to block incoming traffic, outgoing traffic, depending on the rule and how you architect that. It will depend on you, and we'll get to some of that as well. Now, there are two DNS services that are offered by Azure in general. One is the Azure VNet-based DNS, and then there is the Azure DNS. So the VNet-based DNS, it's the built-in DNS support with Azure VNets. So as soon as you create a virtual network, there is a DNS support that's given to you. That's both to communicate with the resources within the virtual network, as well as resolving and going to the internet. It's usually sufficient for some specific cases, like if it's if it's a very simple setup, there's not a lot of complexity, you probably can just use the VNet based DNS. But you still may need your own DNS server for some other reasons. So if you're thinking that, hey, if I have a domain controller, and typically we used to put DNS features or DNS servers on the domain controller for resolving, you may actually still need that if your network or if your environment requires an Active Directory. And otherwise you may need a DNS server in general to do the local hosts resolving. But for most part, VNet actually supplies that to you directly. You don't need to create a new server to provide that services. Okay, and then you have the Azure DNS. This is actually Azure's DNS hosting solution. By hosting, I mean that you can actually host your public DNS zones. If you own your own domain name and you are going to be the authoritative, zone provider then you can actually do that with Azure DNS rather than your hosting provider. So folks who already, if you have done or if you have ever set up a domain name on your own and you're hosting the DNS zones somewhere, you can actually bring that to Azure DNS. It's not a requirement. I mean, if you have a domain name provider who provides the hosting of public DNS zones, maybe you don't have to worry about that. But Azure provides you that DNS services, and obviously you can notice the difference between these two, right? It's totally two separate things. I have seen people talk about, hey, my Azure DNS server was doing that. Actually, what they really mean is the Azure VNet-based DNS server that they are talking about. Okay, so the VNet-based DNS is actually applied, as the name implies, on the VNet directly. So let's say if you have a domain controller and you want to use the domain controller's DNS feature, you can actually go to your VNet and say, all my servers should get the domain controller as the DNS server. That's the only way you can actually have a domain controller. And if you are doing this in real life and you want to join a server to the domain controller, you have to have the domain controller's DNS. So that's where you may still need your own DNS server, okay? But for the most part, it'll take care of everything else. Azure Load Balancer, this is actually quite unique to Azure as well. If you're already familiar with load balancers on premises, it's exactly the same thing, except that this is built in with Azure. So you can actually just go and spin up a load balancer. Azure will do that for you. You don't have to get an appliance, or obviously it's not going to be a physical hardware, but you don't even need a virtual appliance to go and do that. What's Azure Load Balancers used for? It's used for creating high availability. So you have a bunch of servers and you want a load balancer to, load balance between those, and at the same time make sure that your application is highly available. It will take care of that. As we know, it has the layer 3 capabilities because it's a network load balancer. There are other load balancers, and we'll get to that. But for Azure Load Balancer, whenever we talk about it, it has the layer 3 capabilities. There are two types of load balancers in Azure. You have to remember. Um, both for practical as well as your exam purposes. There's a public load balancer and there's an internal load balancer. It essentially does the same thing, except that the public load balancer has a public endpoint, means your users can actually hit to it from the internet and get to that. Um, you have to also remember that load balancers have two SKUs. One is basic and one is a standard. Okay, and they have different features, and we'll get to that in a different lesson. So there's a little diagram over here. This is the public load balancer that we are talking about. So let's say you have three virtual machines. For this purpose, this is a web tier. So let's say these are your web servers. Your users come from www. Dot your domain name .net or .com. It comes on port 80. The load balancer actually takes that and it distributes traffic to all these three virtual machines. If one of these three virtual machines go down, it will recognize that and it will only load balance between these two. So it helps your fault tolerancy depending on how your application is designed. So what the public load balancer obviously does over here is that it will have a public IP address, right? So a public IP address will be assigned to this public load balancer. The difference with an internal load balancer, it's essentially doing the same things over here. In our diagram over here, this is the database tier. So obviously this website is probably using a backend database to get some data. So what we are basically saying is that, hey, there are three SQL databases over here. So this virtual machine will again find out from the internal load balancer to to get the data from one of those three over here. If one of them go down, this load balancer will help facilitate getting the resources from the other two. So internal load balancers, this IP address over here, it will actually be an internal IP address to this virtual network, right? So this is the virtual network. Everything is contained within this virtual network, including your load balancer here. So the internal load balancer only will take an internal or private IP address, and it will also distribute to a private IP address. For the rest of the purposes, most these load balancers are quite similar. Obviously, the internal load balancer, when you say that this load balancer is going to be internal, you cannot assign a public IP address over here. It has to be a private IP address. Okay, we'll have a separate lesson going over this and going through some practical examples if you're not fully clear. But for now, remember private and public IP, and it all sits in one virtual network. Now, the next thing is the Azure Application Gateway. This is actually used at an application layer, and it can be used to load balance services. So, the previous one was a network load balancer. This is an application load balancer. So it goes beyond Azure's load balancers. So, the previous load balancers we talked about, this is beyond that. This application gateway actually will allow you to do SSL offloading, URL path routing, advanced affinity based on cookies. So based, as you can see from the previous load balancers, this is actually a little bit more advanced. It can be used as a WAF or web application firewall. I'm not going to get into details of that. Basically, what it does is it protects your web apps from vulnerabilities and exploits. So I have a little bit of a example over here. So you have users coming into your application gateway, and your application gateway will have, let's say, it will have the WAF feature if you have enabled that, or it will do a layer 7 load balancing, or which means that it's application load balancer. Based on how this is set up, it will throw traffic to different set of servers over here. Um, as you can see from this diagram, we are doing a little bit of URL path routing. So if they're coming to contoso.com/images, it will actually send it to this set of servers. If we are saying that go to the videos, contoso.com/videos, it will know that I have to go to this set of virtual machines to get those videos. So it's load balancing at a layer 7. At the same time, the WAF feature over here, typically we have used other network appliances to do that on premises, but you can actually enable the WAF over here it's a virtual WAF. It'll do most of the, you know, it'll do most of the services that is available today on a different vendors' WAF appliances. I'm probably a little biased because I've used this. It's not, it will help, this WAF will help you quite a bit, but I have seen that, vendors who are out there who actually have, WAF as a WAF appliance or WAF hardware are a little bit more robust. Microsoft's, this is a pretty new offering. I wouldn't say super new, but it's a pretty new offering. They're still maturing, and I mean, you can use it in production, but it does not have all the features you may be used to from other web vendors, right? That's what I really mean. But for the most purposes, it actually works pretty well. And you can do SSL offloading. So if you're doing HTTPS traffic, it'll take your HTTP traffic. It'll do the certificate authority over here. It'll offload the certificate from here as well, or the SSL offloading from here. So which is pretty cool. Next is the Azure Traffic Manager. If you are used to on-premises global load balancers or GLBs, this is what actually a GLB is. So Azure Traffic Manager, for everybody else, it's a DNS-based traffic load balancers. Yeah, that enables distribution of traffic to services across global Azure regions. So in my previous lessons, I've talked about different Azure regions. So let's say you have a region in East US and you have another region in West US, and you have resources in both locations. You can have Traffic Manager globally load balance between those two. I'll give you a typical scenario. If you have a production environment and you have a DR or disaster recovery environment in a different region, your Azure Traffic Manager will help you do that. It will figure out that, hey, something has happened in this region, probably a disaster of some sort. I now have to route traffic on the other side. It also uses DNS to direct client requests to the most appropriate service endpoint based on traffic routing method and health of the endpoints. So the health of the endpoints is what I just explained. If one site was down, it will send to the other site. But appropriate service endpoint means that, let's say you are a global organization, you have uh, resources in North America data centers of Azure regions, or you have it somewhere in Asia or Europe, somewhere over there. If you are using the traffic manager, the routing, you can have a routing method where if the traffic is, let's say I'm in Canada, and if someone from here is actually hitting the traffic manager, it will know that this person is geographically located over here. So I'm going to serve this person from the Canadian data center if they have the resources there, or North America anywhere in US somewhere. If they're from Asia, then they are not going to bring me all the way to the data center here. And if I have a data center, let's say somewhere in Singapore, it will just go and hit the data center over there. So it can actually intelligently find where you are generating the traffic from or where users are coming from, and based on the data center closest to them, take them over there. Right? It's pretty cool. Um, What Azure Traffic Manager can also do, like I mentioned, is load balance between Azure regions, but it can also load balance between on-premises data center and other cloud providers. So if you have a data center that's your on-premises today and you have something on the cloud, you can have Azure Traffic Manager actually point to both. It's not only meant for Azure resources. So I don't know if you guys can already think about it. It could be used for hybrid networking, right? So let's say you have your on-premises network, and for some reason you say, I'm not going to invest anymore in physical hardware on premises. I'm going to have my DR site on the cloud somewhere. Your Azure Traffic Manager can send traffic to your data center all the time. But something happens to your data center, it will know that I have to take it to the DR and it's on the cloud. And it's between cloud providers as well. So if you have resources on Amazon's AWS and Microsoft's Azure or Google's cloud services, you can actually have Traffic Manager globally do that for you in a hybrid scenario. So it's actually a pretty cool thing as well. And as you will learn when I go through the lesson of Azure Traffic Manager, how easy it is to set up. So by now, with some of these components, um, you will start to appreciate, like I mentioned, that doing this on premises would require a lot of planning, purchase of hardware, setting them up in the cloud on Azure. uh, these things you'll still have to know the basic fundamentals on how you're going to use it, but implementing those are going to be so simple, right? This is what makes cloud very unique and very cool that way. So the next thing is service endpoints. It's a newer topic that's coming in the curriculum right now. What the service endpoints does, and this is a little complicated, so if you are not getting it right away or you don't understand what I'm talking about, don't worry so much of it by now. It's usually infrastructure as a traffic to platform as a, I mean, usually we know that infrastructure as a traffic, I mean, as a service as traffic to platform as a service go over public network, right? So let's say I have a virtual machine and I'm going to use Azure's storage service or Azure's SQL service. That means I'm going from infrastructure as a service to a platform as a service. The way this would work is that the virtual machine's traffic would go over the internet and come back to Azure's whatever the storage service, or let's say in our case that the example I'm giving is SQL, it will go over the network. So for certain scenarios, that was not really um, what people wanted because of security reasons, and that's why this service endpoint was born. It basically allows you to filter the inbound and outbound traffic to Azure resources, right? Primarily platform as a service. So looking at this diagram, I hope this will actually make it a little clearer. Um, this is a virtual network. That's what we are talking about today, right? I mean, one of the things we are talking about today. And this is a subnet within that, and there is a virtual machine. This is a this is an Azure storage. It's a platform as a service. So this is infrastructure as a service side, and this is the platform as a service side. So if I wanted to use some storage over here, I would use the public endpoint of this. And before, or traditionally, the way it works is virtual machine would go to the internet. From the internet, it would come over here. That means some of this traffic would traverse through the public internet or the public network. What service endpoints is coming and saying is that what we are going to do is we're going to build you some sort of a, I'm not going to say tunnel, but some sort of a connectivity where you can go to this PaaS service. In our case, I mean, in this diagram, I'm saying Azure Storage, but the example I was giving was SQL. Let's say this web server is going to get some SQL data. It would actually go through this service endpoint and it will not traverse through the internet, right? So the traffic from this VNet um, to this service will always remain on Azure's own network. So this whole thing will happen within Microsoft Azure. Now, the benefits of that is it improves security. So Azure services resources so these resources are bound to a virtual network. And you can remove the access to this platform as a service completely. Now, not to get too far with this, typically when we do audit of an environment, if you are doing some formal audit or compliancy, the issue was, hey, my virtual machine over here is a web server. It's trying to go to this Azure storage or this Azure SQL, any PaaS service over here to get some data. I don't want it to go over the internet because even if it's a secure traffic, there are ways to actually, somewhere in a man in the middle attack or whatever, So from a compliance purposes, it used to be a little challenging to explain that. So Azure decided that we are going to have a direct connection in such a way that all the traffic will be within the Azure's backbone network. It will never leave Microsoft Azure, means it's going to be very secure because Microsoft's own infrastructure and data centers are, they're compliant to most of the major compliance bodies out there to the teeth. Like they're very secure. So that's how it was created. It's a relatively new topic that's there in the curriculum. It's a new service that's there, and I definitely have used it, and it's quite helpful if that's one of the scenarios you need to know that hey, infrastructure as a service to platform as a service. I don't want to go on the internet. How can I secure that? Service endpoints will help you with that. Now, let's talk about a little bit about routing. So, in general, I want to talk about user-defined routes. So, when you create a virtual network in Azure, it also provides you the gateway to actually have your virtual machines reach out to the internet, right? If you cannot reach out to the internet, mean you cannot basically serve the users who are coming in if it's a web server or something like that. So it's provided for you and it provides you a default route to do that. So in the next lesson, when we will build a virtual network and a virtual machine, you'll find out it already goes to the network. You and I are not going to create any gateway or edge device to actually do that like we would have to on premises network, like have a router or a firewall or an edge appliance to send the traffic out. We'll not have to do that because VNet actually provides that to you, which means it provides the default route. What user defined routes or UDRs they do is it allows you to create the rules in the route table to alter that default behavior. So some people might say, okay, Azure is providing me a gateway to get out, but I want to control that maybe because I want to do some packet inspections to see what kind of traffic is coming in and going out and doing all of that. User-defined routes actually allow you to do that. Many organizations don't need it because they're probably okay with Azure's default routes and the gateways to go out, but you may need that for certain specific reasons, and we'll look into that in a little bit. Next to the BGP configuration, so Azure will allow, this is actually a very advanced topic, but it's a border gateway protocol or BGP configuration. Azure will allow you to do some configuration for dynamic routes between your on-premises or your Azure virtual networks in a hybrid scenario. So if you're using a BGP to actually do your dynamic routing, Azure will allow you to actually configure that on your VNets to help you update with the dynamic route updates and everything else. So it's a feature. You and I are not going to do that because I don't have a setup for doing that, but that's something you can definitely read up and look into. And if you're going to do some of this in the practical environment, there's a lot of resources online in Azure Docs where you'll find the information to do that if it is actually applicable to you. The next thing I want to talk about is forced tunneling. This was there for a while, but it's quite recently been introduced to the curriculum for 7533. Is it's it's a special UDR, so it's a user-defined route, but it's a special. It forces all traffic generated in Azure VNets to on-premises network. So basically, any network that wants to go outside or communicate, you're forcing it to your on-premises data center. Now, for some of you, you're like wondering, why would I ever need that? Well, in a hybrid scenario or even just a cloud scenario, the requirement for your organization might be to once again look at the traffic or see a specific type of traffic. So you are basically saying anything on your virtual network on the cloud will have to go through your on-premises network because you're going to send it through an appliance or send it through some sort of a security protocol which is implemented on an appliance. That's what forced tunneling will do. That hey, any traffic on my cloud network has to go through my on-premises network. So there are business cases or use cases for that as well. And the term in Azure that's used is forced tunneling. Like you're forcing it to tunnel through to your on-premises network. So I'll leave routing at that. There's not a whole lot Azure exposes to you from a routing point of view, and you don't need more than this. So for most purposes and for the exam, these two topics are more than enough. Now we'll talk about virtual network connectivity. And when I looked at this topic, I was thinking that what does it mean? I mean, everything in virtual network is connecting, but what from Azure's perspective or exam perspective, this means is it's all about connecting between networks, right? So from connectivity to Azure VNets from outside Azure network. So if you have a hybrid scenario, like let's say you have an on-premises network, you want to connect it to the Azure's VNet, uh, it's basically VPN, right? Your virtual private network that you are creating through Azure to Azure VNet. So you can have a point-to-site VPN, means you have multiple users who will have a little application on their uh, desktops or laptops or whatever, and they will click on connect and they'll connect to your VPN and to connect to all the resources that are available to your VNet. It's a point-to-site VPN. If you are already familiar with point-to-site for your organization on premises, the concepts are the same. Your users just VPN in. Then there's site-to-site VPN, which is typically more used in a hybrid scenario where you have your data center and you have your Azure data center and the virtual network and everything you created on that, and you want to create a connectivity between those two, right? And you'll be doing that on a private network. You don't want the data or anything to traverse through the public network. So you'll be using a site-to-site VPN. Obviously, the VNet supports that. And then you have the Azure Express route. This is actually quite unique to Azure Cloud. And what this does is that basic site-to-site creating is easy. If you have done this before, you know you need two appliances in two sites. You'll probably use SSL-based VPN or IPsec VPN. What Azure Express Route does is that if you have a lot of bandwidth requirement between both Azure and your data center, or you need it to be very stable and dedicated, that's what ExpressRoute does. It's a direct circuit that's created between your data center and Azure data center. It's not something you and I can just click and make. It's quite simple to set up from Azure side, but from as you can imagine, it's a direct circuit. So what will happen that you might have to talk to your ISP or internet service provider who's providing internet to your data center to actually, look into how they can have a direct circuit to the closest data center. It's actually quite common in large businesses or businesses which require that kind of security and bandwidth uh, between Azure and their data center. If you have a huge organization with a lot of servers, a lot of devices, a lot of things, and you want to have a direct circuit, ExpressRoute will do that. Now, the next thing is VNet peering and VNet to VNet connection. It's pretty similar. It's just how they do it. As you can see, I left a little bit of a gap over there because as you can imagine, the point to site to site, and Azure Express route, they were very much external outside Azure network, like your data center or something else. VNet peering and VNet to VNet connection is when you want to do connectivity to another data center or you want to do it to another network, which essentially to your VNet looks like an external network, but it's also created on another virtual network. So let's say you have organization A and organization B. Back in the days, a site-to-site VPN would be a typical site-to-site VPN that we were just talking about. But since from Microsoft's perspective or Azure's perspective, this organization is also in Azure, that organization is also on Azure. You can have a VNet to VNet connectivity directly, or you can have a VNet pairing uh, that will allow you to do similar thing like the first 3 points over there, except that they're all already on Azure. They're not outside of Azure, right? So it actually makes things a little bit simpler, as you can imagine, that hey, we both are already in Azure, so why do we have to go through crazy other site-to-site VPN things? There should be something through Azure's backbone that we can do, and that's what Azure is exposing over here that you can use to get that connectivity or direct connectivity between that. And we will actually see the VNet pairing quite a bit because it's a pretty good use case or simple use case that you'll find quite easily if you're coming from on-premises and you need similar network setup on your Azure side. And the other thing is the Azure Virtual Network Gateway. So when we do a site-to-site VPN or even a point-to-site VPN, Azure Express route, or VNet to VNet connection, except the VNet peering, you will need a gateway. It's like a virtual appliance that Azure will provide you. It's quite transparent on how Azure is doing that, except that you'll request for a gateway from the portal or command line, and after a few minutes, it will spin that up for you, and it will expose you to the configurations, only configurations that you need. Azure will do the rest of the stuff for you, the setting it up and everything else. And it can happen in minutes. And this is where you kind of start thinking, I mean, or at least looking at your on-premises network and thinking that, wow, if I have to do all of this on my on-premises, the kind of hardware I'll require, or the kind of software I'll require, appliances I'll require, and in Azure, you can do it in a couple of clicks, right? So it's pretty cool. All right, guys. So I'm going to leave that session there. I'm not going to go further in this lesson because there's a lot to absorb here. Like I mentioned earlier, that if you did not understand a lot of it, don't worry. Start going and looking it up in Azure Docs and getting yourself familiar. In the next lessons, we are going to actually start configuring virtual networks. We are going to start having gateways, load balancers, and I'm going to get deeper into those topic and see and have it all come together with public IP address, private IP addresses, gateways, UDRs, and it will start making more sense at that point. Okay, but I know this is a lot of to observe. It's very theoretical and conceptual, but these are the fundamental building blocks that will take you to the next step. And this is when you actually get into the core of Microsoft Azure and start appreciating what cloud platform can do for you. Okay, so as usual, my training site is at cloudranger.net. You are most likely watching this on YouTube. I'm going to post the slides. I still get a lot of queries about where the slides are. They're actually all posted on slideshare.net forward slash Sean Ismail. At Twitter, Sean Ismail, that's where you can reach me. Um, there were no resources for this, but what I'm going to do is for this lesson, but what I'm going to do is I'm going to have a bunch of links from Azure Docs in the GitHub location for this lesson. So you can actually go and read up a little bit in front if you want to. And of course, you can connect me on LinkedIn at that specific location. And I have a little request over here that if you think this lessons actually help you and it's letting you help you pass your exam or helping you to do your work, I mean your day-to-day work because you use already Microsoft Azure, uh, nominate me as a Microsoft MVP in that location. If you take this URL and put it on a browser, you can actually just go and nominate someone, choose that, put my name over there, and I'll really appreciate it. Okay. So thank you for viewing and press the thumbs up on the videos on YouTube and like them so I know that it's working for you. And as usual, if you have any questions, just leave it on the comments and I'll try to get to you. All right. Thank you, everyone, and see you on the next lesson.